All right. Hi, everyone, and welcome to another edition of Nordic Serverless with me, Gunnar Grosch. This time we have a special show for you, calling it the Chaos Engineering Special. And today I have a dear friend, Adrian Hornsby, with us, and we're going to talk about chaos engineering and safe deployments and more or less a lot of topics related to how we deliver services within AWS, and of course from a serverless perspective. So let's bring Adrian to the stream. All right. Hi, Adrian. Welcome.
Hello.
So we've got picture and we've got audio, so we're all good.
I actually have to say there is a big delay for me, but so let's see how it goes.
All right. So for everyone that doesn't know Adrian Hornsby, can you please introduce yourself?
Yeah. So I'm Adrian Hornsby. I'm a kind of developer advocate, technical evangelist. I think we change our job title regularly for some reason. I've been working with AWS for about 4.5 years now. More specifically around architecture, resiliency, and in the last maybe 2.5 years, a big focus on chaos engineering, which is kind of I'd say a passion of ours, because I know Gunnar is passionate about it as well. And it's the kind of things I do. I like writing code, I like writing blog posts, and I like meeting customers and helping them in their journey to making things more resilient.
Yeah, that's great. So tonight, as I said earlier, we're going to talk about chaos engineering and talk about serverless, of course, and some of your favorite topics, which is safe deployments and how to, as you say, make things more reliable and resilient. And we want to make it interactive today. So if you haven't already, make sure to join the Slack, the Serverless Forum Slack. You can do that. If you look at the description below in YouTube, you have the link, nordicserverless.io/Slack, and there you join the channel Nordic Serverless. I'll be monitoring Slack for any questions, and feel free to just ask anything about these topics. So to get things started, I wanted us to talk a bit about what chaos engineering is. And as you said, Adrian, we've both been doing chaos engineering for a while, and we do things that are perhaps quite similar. That's why people call us double gangers sometimes. But we both enjoy talking about chaos engineering and has done at several events and conferences around the world. So we're not going to deep dive into the basics of chaos engineering this time, because we've done that before. But just to start things off with chaos engineering, let's just talk about shortly about what chaos engineering is. And from my perspective, chaos engineering is it's a practice of performing controlled experiments to inject failure into a system or an application, and we do it not to, as it's sometimes called, breaking things on purpose. We don't do it to break things, but we do it to learn from the breaking. If things break when we inject failures, we want to learn from those failure modes. Mm-hmm. And in essence, try to make our applications or systems more reliable, more resilient to these types of failures.
And like you often say as well, like me, it's a lot related to gaining confidence, right? I think that's I always take the example of firefighters. It's like you don't send a firefighter fight fire the first day he joins the firefighters. You have a lot of training. You want to gain confidence. You want to make sure you understand how things fail, and so that you're ready. So it's for me, it's a lot about learning and getting confidence, and I know it's the same for you, because you write the same. So
Exactly, and I think it's confidence from several perspectives as well. It's confidence in how the system behaves, and that's one thing. But the other part, which perhaps is even more important, is confidence in how your organization handles failure.
Absolutely, and you're dead on. I think a lot of people see technology as one silo, but actually technology span across multiple facets of the organization, touches whether it's the tools, the culture, and also actually I always talk about the processes and mechanism that work into the organization, and like incidents response and being able to recover from an outage really span a lot further than just understanding how your failure injection works or how your system works. It's exactly how you say is how your team is going to respond under stress, how your team is going to handle the after, how you're going to learn from it, and especially how you're not going to try to fall into the fallacy of blaming people, which is very common as well. And so.
And the perhaps term that has gained most traction is chaos engineering, but there are several different, let's call it practices from different companies and related fields that are being used. And you, as working for AWS, an Amazon company today, you're really familiar with game day practice.
Yeah, we call that game days. I mean, for a long time, almost 20 years now. It's a term that was coined by Jesse Robbins when he joined Amazon in the early 2000s, and he was working on on the Amazon retail site to make sure that it was resilient. And they created game days where basically it was really like going around the data center and try. I always say unplugging things. Of course, it was way more controlled, but the idea was really there. They were creating a small outage, and this was really to improve first the availability and reliability of the system, but really to prepare the team into what it is to survive from an outage. I mean, I don't know if you remember yours, but my first outage, mate, it was like crazy. I remember I was sweating, my heart rate was so high, and I was so stupid. I did so many mistakes. I was slow. I didn't know at all where to look. We were so unprepared, right? And I always tell that I was so unprepared that I deleted the database in production, and I did it twice actually. That's the whole thing. And I think even further, the game days and practicing is good for skill atrophy. Like if you don't practice your debugging commands often, you forget them very fast. Like 2 weeks, 3 weeks, 1 month is enough to not be 100% confident. So I think it's dead on, like learning confidence. It's all around that.
Yeah, and today chaos engineering and game days they are really related in the ways that they are performed often. In many companies use chaos engineering and game days together, so they don't perhaps do chaos engineering all the time, inject failure into their applications on a regular basis, but perhaps every now and then they do game days and then use the chaos engineering practice to inject failure of some sort into the organization or the system.
That's exactly that. And I think also game day is also to try new experiments, new things. It's more hands-on, and then very often what you find in a game day, you kind of tune the experiment, and then once your experiment is tuned, you understand it, you move it into a CI/CD pipeline, and it becomes more like continuous verification. This is how people call it nowadays. Like once you move there. So.
And about that, the term chaos engineering, it's kind of, can we call it loaded? That people have both positive and negative responses to the term. And from your perspective, do you think that is a problem still for people to accept or use chaos engineering?
Yeah, 150%. It's so common. I go to customers, and I mean it's not the problem for developers or for like site reliability engineers or DevOps teams. They love that. In fact, you say chaos engineering to most really hands-on people, they're kind of, okay, cool. What are we gonna break? It's kind of the default assumption, but there's a lot of preparation, a lot of before and after. And if you say chaos engineering to C-level, very often this is where the problem happens, and the reaction is like, "Hey, we have enough chaos in production," and that's the thing. Like chaos engineering is nothing like bringing more chaos. It's actually really understanding and making sense of chaos that you have currently, and removing it. Like and so and in fairness, it is a scary term, and like people would call it resiliency engineering. To some, it's a wider umbrella which has chaos engineering in there, and C levels understand business resiliency, right? And so I'd say I often say, yeah, it's just business resiliency applied to engineering, and then everything is fine. So it's quite interesting.
Yeah, and you touched on something really important there as well with the chaos. That it's not about adding chaos to your system or your application or organization. It's about finding the chaos or handling the chaos that is already there.
Yeah, you're 100% right.
Yes. So moving on from that, then, what do you see as motivations for companies or for organizations to start using chaos engineering? Where does a company have to be able to start chaos engineering?
Well, I'll return that question for you, because like I think I see it from AWS point of view. Like I think from my side, we see companies, they so in the last 3, 4, 5 years, we've seen company migrate to AWS, right, and get more and more comfortable. And frankly, 3 years ago, very few people were talking about chaos engineering. Now, most of companies have, and large companies have fully embraced that. They have big workloads, uh, complex workloads, and so they are more in the next phase. They've understand, they own the cloud in their own ways, and they are going next level now, and next level is like reaching the the 4 or 5 nines of availability, making a system really resilient. So for me, this is where I see it. But I mean, from your side,
Yeah.
what do you think?
Well, from my side, as working with customers that are using AWS, I'd say that a lot of companies would benefit from using it quite early on. You often hear that we're not Netflix. We can't use chaos engineering because we're not Netflix. We haven't gotten to that level of maturity yet. But I'd say that it's probably easier to get started early on, to start learning the practice and start doing perhaps smaller types of either game days or continuous experimenting on your applications. And you don't have to do it in production either. You can start in testing or development and so on.
Yeah. I always demo chaos engineering on my laptop, and actually it's a practice I was doing in my previous companies. Like when we were hiring new software engineers, I would ask them for a week to build a system with a very simple system, and really didn't much matter what they were building, but to make it as resilient as possible, and just to start thinking about the idea that when you actually go into the cloud and in distributed systems, things fail, right? So failure becomes a first-class citizen, and you are not anymore in 100% operational excellence, because at scale, when you have a lot of things happening, there's always something going wrong, right? So you are kind of always in what we call partial failure mode, and this is exactly kind of how do you get confident with this, and how do you build application that actually fail regularly. And when you start locally on your laptop, you can change the mindset from, hey, my application needs to be 100% versus, hey, my application is going to fail. So, I call that failure-oriented development. It's like, when you build a function, when you build a class or you build an application, design it so that actually it will fail, and think about how do you recover from that, and what does it mean for your implementation. So
yeah, that's I think that's a really sound way of approaching it. And one thing that I've seen as quite successful way of starting to use it as well is to challenge the way that companies monitor or use alerting today, because a lot of companies invest a lot of money in state-of-the-art monitoring, state-of-the-art alerting systems, pager calls 24/7 and so on, but you don't really know exactly how it works or if it even works when things break.
exactly, it reminds me of one outage I had where the alarm system failed, and I was and because nobody had tested it, and even the escalation pass failed. So it was exactly this. It's something that also you need to include in your chaos, right?
Yeah, I think so as well, because when you do it all the way through the organization that way, if you inject failure and you actually cause some sort of problem in your application, well, then you'll see how your monitoring or alerting reacts to that as well.
Yeah.
And you can do it in a controlled fashion. It doesn't have, because we always know that alerts, they're never at the right time. It's usually when a lot of people are off, or if it's in the weekend or things like that. But now you can do training that way, and as we talked about before, build confidence in your ops team or live ops team or whoever handles errors or alerts for you.
Yeah, the incident response, I think.
Yes.
And that's all actually it's a great topic, and because I often see customers forget about that, forget about designing an incident response team and actually practicing it. What does it mean, when an incident happened? Like it's actually quite complex. There's a lot of things going on, because depending on the scale of your incident, you might, you need a war room, you need someone that handles the public, someone that might handle any, a lot of different things, and having the role set up, who does what and when, it's all needs a lot of training.
Yeah, exactly.
Actually, I have a question for you, because it's a serverless forum, obviously. What's the difference you've seen with serverless customers versus more like generic EC2 container based, or customers? Do you see a different approach to chaos engineering? Do they have different problems?
Well, the biggest one, I should say, perhaps, is in adoption, and that companies that are entirely serverless. So I've found it to be harder to reach them with chaos engineering as a practice, because a lot of them, first off, they do believe that some of the pros that you hear about serverless are true all the time. Services are always there. They are highly available at all times. So it's not only about chaos engineering, it's about building resilient systems as a whole. That we're used to building circuit breakers, or we have fallbacks for things that are completely out of our control, like third parties. But oftentimes we don't do it in the same fashion for things that are inside the cloud provider. So we rely on services to be there. And since a lot of people do it that way, then we don't even know about what failure modes are there. And I think that's where chaos engineering can be of good help. But no, it's hard to break through with it. Still needs to be more of a something that is implemented in the way that we develop. It's harder to implement it afterwards in a serverless application. I think we need to have it already at the development stage, so that people start using it earlier on. I think that would help.
So do you think it's like a the bias of managed services? The more managed services you use, the less you think things are going to fail, and
Yeah,
kind of okay, interesting.
I think so, definitely, and of course also that perhaps that's true in many cases. Things do fail less often,
Yeah,
and
absolutely.
getting used to that, getting used to not having failures, that's really dangerous, I'd
Yeah,
say.
yeah. It touches on the skill atrophy, that we discussed a little bit before.
Yep.
I mean, Werner Vogel says it very well. Like everything fails all the time, and even things that you think don't. It's hard to fail. Eventually, there's gonna be a failure, even if it's like a few minutes or sometimes a bit longer. It's things fail eventually, and so understanding the failure modes, yeah, it is important, and being able to practice it more than once every 3 year, yeah, is might be important. But there's also, I think, what is interesting, and this is where I see a problem is, what's the cost associated with versus the risk, right? So if you look at the past, you might be okay. How many times S3 has had a big outage? In 13 years, so I think I can recall maybe three or four,
Yeah.
three, that really affected a lot of people. So what's the cost of developing that versus going down?
Yeah.
It's an interesting discussion to have as well.
Definitely, yeah. But a lot of failures that we see, not only in serverless applications or system, they are somehow related to when we deploy things or when we do changes in our application. So I'm not talking about human error, but related to that, we're creating new versions. We are extremely agile. We're deploying more and more often, and that introduces more surface for us to inject failure to, be it using chaos engineering or be it just by accident. So I think not just talking about the different services that might fail, I think it's really important to look at configuration errors that we might introduce by, not having a flexible enough code that can handle issues with our configurations, or not building systems that can handle security policy errors and so on. So introducing those types of failures as well in a controlled fashion can help us make our systems more robust and more reliable.
Yeah, 100%.
So it's not only about services being up or down. It's broader than that.
Yeah, and this is why automation is key, right? And we'll touch it a little bit also in chaos engineering. Like the way you push your code, the way you push your experiment. And I know you avoid to talk about human errors because it's a difficult thing to talk about. But I mean, the more humans touch things, the more errors there are. It doesn't mean it's the human fault. It's like there are not the proper tools and mechanism, and maybe the culture hasn't let people the time to automate things. But eventually, the more human touch something, the more errors there's going to be, especially if you have a high velocity of deploying your code. So, I mean, automation is key, regardless of being serverless or not. And in chaos engineering, it's the same. Like that's why you do game days, maybe to figure out a little bit, poke the system, understand, how things work, and what are the strings you can pull, and then you need to go into an automation. And even when you do the experiment, my recommendation is also to always try to be as safe as possible. And for that, there's also methods like to do safe experiments.
So moving on a bit more to perhaps the experiment side of it, when creating experiments. I think a way to get started is to, if you're looking at your own system, what are the common failure modes that you have today? What kind of issues have you had before? And create experiments based on those. Because many people that build or run systems, they've had years of failures in different sorts, and they perhaps fix those issues, but perhaps the issue might be one that can be recurring, but let's hope that it doesn't come back again. So creating experiments by looking at the past, looking at the incident history, I think that's a great way to get started creating your experiments.
Yeah, you're totally right. And I would add to this, do not try to remember because when you remember, you always are biased, or you kind of try to forget some of them. Or I would say, really, I have a diligence to maybe collect postmortems for the last year and a half or 2 years, and really do a real analysis of it, because I've seen people trying to recall mentally the kind of top five failures that they had, and when you look at the data, it's totally different. Actually, it first thing, when a human tries to remember, it's never gonna remember human errors. It's always gonna put the blame on the system. It's something went wrong. But so you tend to forget all the deployment errors or deployment outage and things like this. But yeah, so very often when you look at it, I mean, for me, this is deployment outages and configuration drifts. It's like they are up there very high in terms of outage. And then, of course, the kind of the early, what I call the early failures, is everything like timeouts and things like this retried before you had enough outages that actually you started to fix the default timeouts. So they tend to reduce over time. But the deployment outages tend to happen very, very like randomly. So it's
So I was thinking about perhaps moving over, just showing a couple of example experiments from a serverless perspective.
Yes.
See, let's give me a second. Let's see. There we go. Now hopefully my screen should be visible. So looking at chaos experiments for serverless, these are some of the common ones that I build experiments around. Looking at the way we handle errors by just injecting errors into our serverless application. And that can be in different ways. I'm going to show you a few examples later on. Timeouts is perhaps the first chaos experiment for serverless that was created. How we use timeouts in, for instance, our functions or between services is really key when building serverless applications, and confirming that these are correct when we're in the steady state. That is the state when everything is working as normal on a day-to-day basis. That's fairly easy, but defining the timeout values when when there is an error, if we have latency in services and so on, that's one great way to do chaos experiments, to inject latency and test our timeouts then. And a lot of serverless applications and other applications as well these days are built around, they are event driven, so they're built around events. And how we handle events in our applications is really important. So what happens to events if there's nothing there to respond to it? Do we queue them correctly? How do we how do we fan out our events and so on in our applications? And injecting events that are perhaps corrupted or doesn't contain the correct information is another way of doing experiments to see what happens. what happens in our application.
And load test your events to see if concurrency can handle it, and you don't go through, back in the days when Lambda, for example, was in VPC and you had to attach an ENI, you could easily reach IP address limits in your accounts, these kind of things.
And then we have the fallbacks, like we touched on before, that we count on services to be there all the time, but what if they aren't? What if, hopefully not, but what if DynamoDB doesn't respond? What if S3 has its fourth major problem? Or if a third party is down? That's perhaps the most likely one. So having fallbacks for services that aren't acting the way they should, and testing those to make sure that it works as intended.
It's funny because I had the discussion with Marcia. Marcia, who's an evangelist in Nordic. She's also a serverless hero. She used to be a serverless hero, and we talked about the failovers. And she said she never implements the circuit breaker when it's, for example, Lambda calling Dynamo, but always implements it when it's calling a third party. And I mean, as I think it makes sense to implement, to have circuit breaker in your framework, and if it's in your framework, it's free to use eventually, right? So for anything, so it's, I think, always a good practice. Now, you don't necessarily have a failover. You might want to just fail fast as well, and being able to surface the error. But in my opinion, it is a big problem to go to third parties, because you go over the internet, and the internet is like it's a hard place to send a request. It's a dangerous place.
And one common thing that I see is that a lot of companies build serverless applications that are single region. So they aren't always using multi-region for serverless applications, because how often does a region go down? That's not that often, but it might happen. But there are other things that can affect as well. Just think of a major ISP having issues reaching a certain region. That might affect a big part of the customer base.
Yeah.
So,
I mean, a region. I mean, I've never seen the whole region goes down. It's usually critical services in that region that then tend to have a cascading effect on some of it. So it's like, it's going to be, let's say, 5-6 services that you use, and the region goes down. But actually, the big region going down that happened is often DNS, right? It's like your DNS is all of a sudden blacked out in that region, and then that's a big problem. So do you do a region evacuation, or do you wait the storm to recover? It's a hard question. I think it, and my opinion here, it really depends on the company and on the business. I think sometimes if you're automated, it's actually very fast to rebuild your service in another region versus having it there all the time. I think that's also something that I think is important, is the mean time to recovery. If your mean time to recovery is redeploying your whole stack into another region, and it's pretty fast, you might not need an active, but at least you need to practice being able to recover fast and redeploy fast in another region. So that's definitely this kind of experiment that I would do. You black out the region, so you force a redeployment of the whole stack until the DNS is propagated. And usually this is what surprises people, is, it's like, okay, you can redeploy fast, but all of a sudden your DNS doesn't propagate fast enough, or there's something going on in there, and then it fails.
More practical then, just a simple application here with Amazon API Gateway in front of 2 Lambdas, one having S3 as a downstream service, and one having DynamoDB as a downstream service. So looking at the ones we saw just now, we can, as I said, inject errors into our code, into the Lambda code. So perhaps we're giving a different response instead of the standard 200 when everything is okay. But we can also alter the concurrency of functions to see what happens if we reach the cap for concurrency. How does our application handle that? If we're using graceful degradation and so on in a correct fashion, so that the users don't really see that there is an issue. And of course, we can restrict the capacity of DynamoDB tables. That might be to perhaps simulate that there is an issue with DynamoDB that would give us a restriction of the capacity. And other ones, like I talked about before, quite common issues are related to configuration in different ways and to policies. So we can introduce those and do it fairly easy. You don't really have to have any specific tools to do these kind of experiments. You can do it more or less using the CLI, or perhaps using, even the console if you wish.
So let me ask you a question, because this is interesting.
Yep.
We talk, of course, applying chaos engineering to security, right? I think this is basically also what you're touching here. When you say security policy errors, what kind of experiment and kind of how do you go about executing that experiment and verifying? Is it about detecting the change in the configuration, or how do you do it?
Well, this can, as you know, the related field of security chaos engineering, I think this perhaps is more in line with that. But it might be simple security policy errors, like perhaps prohibiting things, that it restricts what you're able to do instead of perhaps opening up a security breach. So that's one way. And then it's fairly easy to do it by modifying your whatever service you're using, the IAM permissions, for instance. But the other way around is instead, if it's something that is too permissive. So you're deploying something that perhaps is giving more permissions to services than it perhaps should. So then it's more of a matter of detecting those issues. And I'd say that this is more related to security chaos engineering, the field that Aaron Reinhardt and his buddies have really starting to grow these days. So that's a really interesting take on using both security and chaos engineering together.
Yeah, there was a fantastic talk by Kelly Shortridge as well a couple of years ago last year, at O'Reilly, about using chaos engineering for security, and it's exactly this. It's the idea, of introducing a failure that could, prompt big security issues, and is like, what do you do? How do you respond to this? They're very similar to responding to an outage, but instead responding to a security breach. It's kind of, it's very interesting how they're bridging those two worlds. I haven't bridged myself yet to security, because my knowledge on security is not to the level that of those experts, but it's definitely a field that is super interesting, and I'm looking at it. And
I'd say that it's the same for me. It's you need to have some security competence, of course, to do it, but I totally agree. It's a really interesting field, and a field that I think, once again, with the bias of managed services, I think security breaches, we've seen some quite large ones. Was it Capital One 1.5 years ago or something like that, where companies use serverless and fully managed services, and you rely on those services to be secure. But as we know, it's really up to how you use your services, how secure they actually are. So doing these kind of, let's call it proactive experiments related to security, I think that's really important and will be more important.
It's detecting change, right? I think because by default services are pretty well secured. Like S3 buckets are never open by default and things like this, right? So changes happen, and detecting those changes and then remediation and understanding just understanding actually how to remediate those, it's not necessarily straightforward. So it needs practice as well.
And then we have the last one on this slide, which is around disk space for functions. And disk space is something that perhaps we don't think that much about, but in certain applications, certain things that we do, we need to use the disk space of our functions, be it Lambda or Azure functions or Google Cloud functions. We're perhaps doing something with images, or perhaps using it as a cache of some sort. And that's another part of these types of services that we rely on to be there. So we can inject those types of failures as well and fill the temp disk, for instance, or perhaps make sure that we aren't able to write to it, to see how our code handles those types of issues as well. And that brings us to the mother of all chaos experiments for serverless, which is latency. And it's the one that I think we've both spent most time with, but it's also one that can reveal a lot of weaknesses in our applications fairly easy. So adding latency, we can show what happens when we have cold starts. Cold starts is something that perhaps is less of an issue today with the improvements we've seen around Lambda, but cold starts isn't only for the first time something is called. It's also when our application is scaling. So AWS needs to spin up more containers in the back end to handle our Lambda functions. So we might have cold starts even though our application is being called frequently. And adding latency to every 100 call or something like that means that we're able to simulate how exactly a cold start would look for our users. Another one, of course, is just to simulate cloud provider issues. If there is an issue with the underlying infrastructure, it might give us latency. And as I talked about before, the way our application behaves when we are in steady state is not the way it will behave when we have latency in our application. So that's an easy way to simulate those issues as well. But of course, also other types of runtime or code issues. But perhaps the most common used one is the integration issues. Integrations to downstream services like other AWS services or for third parties. Let's say we're using Twilio, or we're sending notifications to Slack and so on. Just last night, I think Slack had a big outage. And what happened to all of the applications that were using Slack in some sort for as a third party? Well, those kind of issues we're able to test by using these kind of chaos experiments in our applications. So those are some different kind of chaos experiments we can do for serverless. And perhaps, is it a good time to show an experiment, Adrian? What do you think?
Yeah, man, do it.
That's a good segue, I think.
I think it's great.
So let me.
Especially, I think you develop a nice UI. I have the Lambda stuff running as well, but I think it's much nicer to see it in yours.
Yeah, we can use this one to begin with, at least. So this is a simple site I built just to demo how we can use these kinds of experiments in a serverless application. And as Adrian said, it's just a UI to show off exactly how it works. And the application in itself, it's fairly simple, as the one I showed before. In this case, we have 3 Lambda functions behind an API gateway, and we have a DynamoDB table behind those. So for every call to API gateway, the Lambda function fetches, in this case, an URL from DynamoDB, and then the client loads an image from S3 based on that URL. And we, in this case, will be using an NPM package that's called Failure Lambda, which I and a few others have developed. And it's more or less a rip-off of what Adrian Hornsby has built, but with some slight improvements, if I may. So the NPM package has several different failure modes that we can use. We can add latency. We can inject status code. That means instead of returning a 200 call or a 200 response, we can return whatever status code we wish, like 502 or a 404 and so on, to see how the application behaves. We can throw an exception. We can inject space or remove space from the disk, rather, inject big files. Or we can do a blacklist. And blacklist means that we're hijacking the calls to services. In this case, in the example to the right, we're blacklisting S3 and DynamoDB, but that could be any call, so it can be to a third party and so on as well. And the package works, or the Failure Lambda works by wrapping the handler, the entire handler of the Lambda function, and then we're controlling it using a parameter in Systems Manager parameter store. So
that reminds me that I need to update my library to catch up with what you guys have built.
Yeah, do that. So Adrian has a library that's for Python instead. So this one, NPM, so it's for Node.js. And Adrian has one that's for Python and works more or less in the same way. So let's try to inject some errors into our application. So this is the site, and right now it's working as it should. So every 5 seconds, it's reloading function 1, function 2, and function 3, which, as I said, it's getting a URL from DynamoDB and then loading an image. So right now, the failures are disabled. So we're doing this using, as I said, a parameter in parameter store. So we have one for each function. Loading the one for function 1. So it's basically JSON in this parameter. Right now it's saying that it's is enabled false, so it's not enabled. We can set the failure mode. So we're choosing which type of failure we want to inject. In this case, it's set to latency and with a rate of 1. And the rate tells you how often it should inject the failure. So rate of 1 means that it will inject failure on every invocation. If we set it to 0.5, it will inject failure into roughly half of the invocations. And right now, since it's latency, we inject a minimum latency of 100 milliseconds and a maximum latency of 400 milliseconds. So let's enable this. Right now, I'm doing it through the console, but normally this would be done using CLI. I'd say that that's easier. So you just do a simple CLI call to enable it, and then you're good to go. All right, and switching back. So now on function 1, we should, for each invocation, get an additional 100 to 400 milliseconds latency added. And this function, it still works. We're still getting a new image. It just takes a bit longer. The other ones, as you can see, function 2 and 3 is around 200, 300 milliseconds, and the other one is now above that. So that's an easy way to add latency using this npm package. So let's quickly look at the other ones as well. So instead inject. Yeah, sorry.
No, I'm saying like, okay, I know, I'm pretty sure you're going to talk about it, but like, what's your suggestion then? You know, when for example things like this are slowing down on the UI, what can you do and things like this?
Sorry, can you ask once again?
Sorry. Yeah. So you're doing your experiment, and sometimes, of course, latency is going to happen. So.
Yep.
What can you learn as a UI designer to kind of improve that? And this is the whole point, right? We are doing an experiment. We want to learn and improve. What are the kind of tips and tricks that you can give to people on the stream to kind of?
Well, yeah. So one thing is, I think for me, it's mainly around the user experience. So looking at what is the experience for user if there are these types of issues. So if latency is added, is that affecting the experience for the user? Then we probably need to find a way to improve it. And that might be in different ways. It might be using graceful degradation, so that if it's bad enough, we actually remove things or functionality from the application. I think the Netflix example that we hear every now and then around this, I think it's a great one, that their way of graceful degradation is to actually remove, for instance, categories from what you see in the UI.
This is especially when your UI calls like say 20, 30, 50 microservices, right? This is why it becomes important. Like now you have 3 functions, so the probability for one function to going bad is not high, but as you have 50, maybe 100, I mean, Amazon.com has thousands of services call behind the retail page. It's very common that a couple of them are going bad at any point of time. And this is exactly what you do. It's like, okay, you give it a quota of time to get a response. And if you don't get that response, instead of waiting, you just say, oh, let's remove that from the UI and recompose and kind of still think about the user experience. And all this is learned actually by doing this chaos, what you just do, right? So
yeah,
it's super useful for UI designers as well, right? And this is just a proof.
And that's what you're touching on here is how the importance of including everyone in these types of experiments. So it's not just a matter of the people building the backend to see, well, it's still working. We're still fetching images, but it's important that front-end developers are included as well to see that, because they are probably the ones that will know that user experience is not as good when we're having these issues.
Yeah, and very often, I mean, we don't think about including this kind of stuff in specifications, you know. So when you go about forming an hypothesis, then this is also why it's super important to actually include everyone, right? Not just the backend developers. I know a lot of people do this. We get the backend devs and do some experiment, but you get half of the story because you totally forget user experience. So I think embracing the experiment from the user point of view, it's actually a lot. I mean, the way you do it with your demo is exactly that. You know, it's like you see from the customer point of view what's the result of your experiment, right? And it goes back to this steady state, right? We often talk about the experiment as a steady state on the the business metrics and the backend metrics, but actually UI is a steady state as well, right? What is the normal operation of your UI? What is the baseline for your user experiment, right? And having kind of this kind of view on how to to monitor the change of user experience or user happiness. I think that's the term that is being used nowadays. It's super important. And just
I think you've included that in some of your talks, that how user experience has affected, for instance, how many searches there are on Google and so on.
Yeah, and and this is latency. This is based on latency. There was an experiment done at Amazon a few years ago where they did exactly what you did. They added 100 milliseconds latency, and then looked at the impact on the steady state, right, and customer experience. Because this is the important part. Steady state should be a part of customer experience, business, and operational metrics, right? So at Amazon, we love to use the orders per second because it includes a lot of these things in one thing. If you can't check out easily, if there's a problem in payment, if there's a problem in the processing of your cart and all that kind of things, it's a bad user experience because you just spend 15-20 minutes or even longer trying to look for something, and then you click and it doesn't work, right? Or I often get irritated when I go to checkout and it doesn't send in Finland, and I'm like, it's like this kind of little things, and this is user experience, and it affects the numbers of orders per second, right? So for us, Amazon orders per second is great, and we did the experiment of adding 100 milliseconds on the UI like that, and for every 100 millisecond increase, there was a reduction of 1% in sales directly related to the orders per second. And that's dramatic at the scale of Amazon. And Google did the same. They added, was it 500 milliseconds? There was 20% fewer search. Yahoo did the same back in the days. It's crazy how latency affects user behavior. So it's all that from Chaos Experiment. It's interesting.
It really is. Let's just look at the second experiment here, which is instead using the failure mode status code. So we're injecting a specific status code, in this case 404, and I've set it to a rate of 0.5, which would mean then that on about half of the invocations, instead of returning a 200 if everything is okay, it will still return this error code 404 for our Lambda invocations. So let's enable it. And compared to the one for latency, this perhaps is more noticeable for users, because when we're getting this issue instead, now we have a 200, once again a 200, so it should be on about half of the invocations. Come on, 200. Now we should get...
The random function is like...
404, there we go, a 404. So in this case, it doesn't load a new image because it's not getting the response it should. So this also shows that, well, we're not having a proper error handling in this front-end application, because the user shouldn't really see a 404 error, but this is just for show. But that's also something like with latency, that knowing how to handle these errors so that the user still gets the best possible experience and having happy customers, as you said, that's something that we can show or test for using these types of experiments.
Did you modify the default timeout of Lambda more than 3 seconds, for example? It would be funny to see increase your latency to 6 seconds and see what happened.
This is no, I think this should still be 3.
Because very often it's quite funny to see like this kind of failure, because Lambda of course has an invocation as a timeout as well, default, right? So
exactly. So let's set a minimum of 2,000 and maximum of 4,000 then. So it might make it, but not every time.
because I mean, by default, the lambda function timeout
There we
is
go. 502.
exactly. So this
So,
is quite funny.
yeah.
It's yet another kind of error. And
Yeah. So since the added latency is more than the timeout value for the lambda, we're getting a 502. So which more or less means that the invocation is stopped by lambda itself. So yeah, it's stuck there now.
yeah.
That's doesn't make for happy users.
Nope.
Um, Then let's just check the last one quickly. The last one is using the blacklist failure mode. So we're able to stop calls to, in this case, S3 and DynamoDB. And we know that this application is using DynamoDB to fetch the URL. So by blocking these, we should not be able to fetch any new images. There we go. So that's also a 502 error. But it basically means that the application isn't able to call DynamoDB. If we looked at this on a trace map, we could see that the call is it's not reaching DynamoDB, so we're not getting the proper response either.
Another fun experiment is just put concurrency to 0.
Yeah,
actually,
exactly.
It's funny as well. It's a different kind of failure mode as well, which happened because, for example, if you go above your concurrency limit, you'll get that error, right? It's good to simulate.
So those are some simple experiments that we can do when we have, in this case, Lambda functions in our application. Now it actually managed to get one through, so
wow.
Still works. And this is, as I said, using the npm package failure lambda, and Adrian has his Python package, which is called chaos lambda.
I guess something like that. Yeah. It's on
chaos _ lambda, I think.
Could be.
We'll post the links. Cool. So that was a bit of a demo part.
So I have some questions for you, actually.
Yes.
So, of course, what's your recommendation, right? Like, people start with chaos engineering. This is a question I get so often. How do we start with chaos engineering? Like, now you've done it on a demo on a site. Imagine that's production. Would you do this like this? How would you do it? And kind of what's your take on getting comfortable with actually maybe reaching production?
Yeah, no, I'd say that you shouldn't start in production. That should, of course, be the goal. But in the same way as you have to learn other new techniques that you want to use, you need to learn how to do chaos experiments first off. And a good way of doing that is to have an as production-like environment as possible, of course. So if you can start by using your staging or a development environment, that's a good way of doing it. But you should start small with your experiments and find those common errors, as we talked about before, and perhaps not the ones you believe that you have, as you said, Adrian, but the ones you actually do have, and build your experiments around those. And I think that doing experiments like injecting latency, that's fairly easy to do, but can still give you quite good results. But other ones that are really simple to do are like the blacklist example here. So like we talked about before, how there's sometimes it's easy to not build your system reliable and resilient in that way when using different services, downstream services and so on. And now with these experiments, you're able to test that fairly easy. So I'd say that start small, start using these simple experiments, perhaps latency and blacklist experiments, and make sure to include the entire team or the entire well, depends on what organization you are, of course, but include people from different teams, so you can look at it from different perspectives. One thing that I've noticed when whiteboarding experiments, you probably learn a lot just by doing that exercise. When you're trying to create your experiment, you have people from different teams in the room. It in many ways it can feel like when you're doing incident analysis, you gather people from different parts of your organization and you talk about the system. I know for certain that I learn new things about the system every time, and exactly the same way when you're whiteboarding or creating your experiments.
There was a very interesting tweet actually from Nora Jones. So Nora Jones is very known in the field of chaos engineering and even further safety engineering, I would say. And she said the most important chaos engineering is, and I totally agree with that, is before and after, right? That's when you learn more, actually. And for me, it's exactly the same, actually. Sometimes when we do chaos experiment, we never reach the fault injection part. The hypothesis part is priceless. You learn so much just by putting people in the room and saying, okay, let's do an hypothesis. Let's say, what happened if my DynamoDB goes down? Or what happened if my Elastic Cache goes down? What happened if my third-party dependency goes down? And then you ask everyone, like from developers, program managers, DevOps, so like everyone in the team, you know, like, what do you think is going to happen? And then by discussing it, like, and you realize people have very, very different ideas or opinion, and sometimes actually don't even have an opinion because they never thought about it. And by thinking about it and by talking about it, sometimes it's just improving specification, it's improving the way we think about systems, system thinking, and the way to go about solving bigger issue. And it's also very nice because it promotes dialogues. And I think a lot of organizations have lack of dialogues, you know, and having these moments where we can all sit down and discuss, you know, what's the behavior and how it should be and what's the best user experience is actually quite a great experience. And the same for the after the experiment, you know, like what went wrong, how, you know, if something went wrong, what went wrong, how do you go about this not to happen again, what's the best course of action to fix the problems, and you know, and then it's changing cultures in a way. I think this is the biggest thing that I've seen is people actually embrace that and really embrace it. It's changing the culture.
Yeah. Continuing on the question you asked, or the answer rather, things to think about. I said that you should start small, and one thing around that is blast radius. We haven't touched on that topic yet, but blast radius is more or less defining how big of an impact the experiment can have. So we want to make sure that we do small blast radius for our experiments, right, small as possible to begin with. And the blast radius can be defined more or less any way we please. It might be that we're just going to do an experiment on 1 out of 100 functions, or it's going to be on one country only, or it's going to be a subset of users, or so on.
Yeah, for me, I always like or prefer to see the blast radius as the number of customers we're going to impact, because then we can try to limit this. Like if I put myself as a customer, I don't care. If I pay for a service, I don't want you to do chaos engineering on me necessarily and put me down. Or, you know, so you need to find strategies to do safe experiments, and you know, and how do you select, you know, who to play with? And there's so many options. You know, I always use the the idea of, the internal teams first. This is a very good place. Your families, your friends, give them account, and then, make them play, and then do chaos experiments on that, at least for the biggest, the biggest blast radius, or the critical services first, to actually learn about that experiment and get your hands on it. But by all means, don't put this on production with your paying customers. Another strategy is also, like beta testers. We use this a lot at AWS. When we create a new service, we tend to embark people into beta test, and this is where we actually also work on resiliency and work on improving the service and make sure that when people are using it, what is the impact? How can we shard our customers into smaller cells and cells? So we call that a cell. It's a potential blast radius, and how do we make this as minimum as possible, and as comfortable as possible? I think, to relate to what we discussed at the beginning, confidence is key, right? So a small blast radius to start with gives you higher confidence, and then with more confidence, then you slowly can get your blast radius a bit higher. But it's super important.
Yeah. Perhaps that's a good segue to a new topic, and I know a topic that you're really into these days, and that's around safe deployments.
Yeah, I mean, I don't know if it's just these days, but it's certainly something that I think is important. But I can maybe share. You should take my screen. Let me share through that. I mean, I don't have many screens, but slideshow. Yeah. Yeah. Do you see it? Yeah. I mean, it's part of what is called, the bigger picture. What I'm talking about is immutable infrastructures, right? It's the idea that, for example, when you do a deployment of a new version of something, you don't do it on place. You actually set up a new environment and progressively roll your users to use that environment alongside the old environment. This is a very safe way to move users to using a new version of the application. I think a lot of people update the application by uploading a new function. In Lambda, I've seen this a lot, especially in serverless, that people create a new version of Lambda function, and then instead of rolling out through a version and then alias, they just uploaded the whole brand new function. And the blast radius here is like massive, because the only way you can roll back is by redeploying a new Lambda function. And if you have to build your package, if you have to have many steps before deploying a new Lambda function or rolling back, your customers are going to be down. So the idea of immutable deployment embrace what is called a canary deployment, and this is what the slide I have. And thinking about deployments and canary deployments for chaos experiments is exactly the same. The only difference here is when the experiment is over, we always roll back. Right? But I love using canaries to deploy an experiment. And the general purpose of that is you have a routing mechanism, and then a version of your application with the experiment and one without. And then slowly you bring traffic to the one with the experiment, and maybe not start at 10%, but 1%, and then slowly grow at 10, 20, 30. And you can grow as long as your steady state doesn't change, right? And the interesting thing is, if you detect problems in your steady state, or if you start to see errors in the log or in your monitoring, then you can roll back almost immediately, right? Because you always have the previous, or you always have the safe environment, which is without the experiment. And you can use this. What is interesting is this pattern is actually it's available on almost the entire spectrum of applications. So you can use DNS, right? You can use DNS routing. So with Route 53, you can in Route 53 there's something called weighted round robin, which I think actually I have it open here. Let me show. So this is a weighted round robin policies that you don't see my screen because now I'm sharing the wrong thing. Because okay, let me reshare the screen. I think it's screen 2. Yes, allow. Right.
And the things that you're talking about right now, that's something that a lot of companies should or are already using right now for their standard deployments as well.
Yeah, 100%. So now you see for this is for example a routing policy for Route 53, and this is using a weighted rule. So you have your domain name, and then you can define some rules, and each rule has a health target. And this is exactly what you can use for an experiment. Actually, I use this for my multi-region serverless backend experiments, where then I can have I can break the health check and see if the system failovers, and that's exactly what we want. We want to have an experiment where it's actually safe to deploy, and we can always roll back, and and without having things affecting your production environment. And I mean, it goes all the way down, because, for example, if you don't want to use Route 53 and DNS, you still have the option of using the Elastic Load Balancer, especially the application load balancer. If you use target groups, then you can give the target group a weight, and again, that weight, and actually you can have even complex routing there, way more complex than with Route 53, for example. And then you can deploy your new target group with your experiment, and then see things there, and make sure that the traffic that is routed to this experiment is also very small, and so you can get comfortable with. And there's another benefit with this is your logs, they are in the environment where you actually implemented the experiment. So it's a lot easier to go back and dig and see in those logs what might have gone wrong or what could have gone wrong. Of course, one way to do it is also to use log tracers, tracers in your request, and say, okay, I'm running the experiment, this request is traced, and then see that. But if you don't have this kind of system in place, then it's much easier using canaries to dig in the logs. And then for serverless applications, I mean, ALB actually can use for serverless, because you can have Lambda function beyond an ALB, right? So the target group can be a Lambda function. So you can also do Lambda functions as compute resources, right? So here it's very important to notice that Lambda can be used for that as well. But if you use API Gateway with Lambda, API Gateway supports this kind of canary directly using stages. So as you create a new stage with a canary, again, you give it some traffic, percentage of traffic, and then you can do your experiment there. And then finally, you can even go deeper than that. You can go on the Lambda function level and create a version, and then give it some weight, right? So it's via alias. So you create an alias, you give it a weight, and then you can have your Lambda function, different version, one with the chaos experiment and one without, and then do your experiment there. It's a bit more complicated to to do that because you have less options on the routing. So this is more like a random type of routing policy versus like, user based. So if you want more control on your users, definitely A and B is very, very good place to go, because you can route based on what's in the header, on your request based on tons of stuff. And Route 3 is going to be based on your domain name, so you can have different domain names associated with different kind of user. Again, it's easy to do that from a client side using feature flags and things like this.
Yeah.
So yeah, but anyway, this is the kind of things I think people very often don't think about for case experiments. So yeah, that's why I wrote a blog post recently around that.
Yeah, that's really interesting, and it's definitely a way of controlling the blast radius that we can use. But as you said, it's you need to find ways how to control it on a user level, perhaps, so that you don't end up with a random failure injection, which might be the case if you're doing it through just the versions.
I need to put the light.
Yeah, go ahead. All right. So in the meantime, perhaps I can start sharing my screen again.
Oh yeah, you have a demo.
Yeah. Let's see.
That's why I love you, man, because you always have demos for everything. I love it.
I like demos. All right. So let me just find the screen share again. Find the right. There we go. Yeah, so I'm gonna show with a similar application like the previous one. Where did it go? To show how we can do this type of canary failure injection. There we go.
Yeah, it integrates directly with code deploy. I forgot to mention that, but it's great.
Yeah, exactly. So we'll see how that works using a live demo. So switching. So I've created another version of this site that instead of the 3 functions, we now have 12 different users using this site. So let's say that each box is a user that's doing something in our application, and they're reloading images. So we want to do a canary release of failure injection to this using the versions in Lambda to see what the effect actually is. So this is the code for it. So it's basically we're using a plugin for the serverless framework for this. Serverless plugin canary deployments. So it will take care of the backend stuff for us for doing this deployment, but it's going to use code deploy. It's going to create versions and so on. I've set it to a canary release using 10%, and after 5 minutes, it should deploy the rest, the 90%, move them over as well. And the way I've done it is to use 2 different parameters. So we have one parameter that is not enabled, and then we have one that is enabled. So right now, all of these functions are using the one that's not enabled. So when I'm deploying this again, I'm going to deploy them and instead use the one that is enabled. And when it's enabled, it's going to use the status code failure mode and inject the 404. So let's do this. Serverless deploy, develop stage and region EU West 1. Let's go. So if the plugin works as it should deploy this. Man, that's slow. It should deploy this, and it should kick off code deploy in the background.
Yeah, and I forgot to mention actually, ECS also supports Canary, and code deploy also supports releasing canaries for ECS and all automated. So it's pretty cool. It's all backed in code deploy.
Didn't happen that much. All right, that's good.
And it's still great.
We'll just have to wait a bit.
Yeah.
So, so what we're going to show here is just what happens when we're doing a 10% release in this. There we go. Now it's starting. So 10% of invocations will then get the new version, which has the failure Lambda parameter enabled. And let's see how that will affect the application.
So did you put the linear canaries, or which one?
No, this one is the standard canary. Okay. So 10% and then the rest.
Gotcha.
After 5 minutes.
Yeah,
so that's the other option, to use the linear one. So then I think you select the percentage and the time, mm-hmm. and it will add X% each time.
10% every 5 minutes or every 30 minutes. This is a linear approach.
Yeah. All right. This was painfully slow. Of course. It worked in test.
Well, no, but you have this. You have the stream going out, so it's like you're using a lot of network bandwidth at the same time. So I wouldn't be surprised if you're hitting the limits of your bandwidth.
Yeah,
I am in my laptop. I cannot do anything like my internet just by even. I'm not even sending the stream to YouTube, but you are.
No.
I'm not.
But we'll keep on talking and let that work in the background. So that's fine.
Do we have questions actually? Because I think this is what was most interesting for me as well, is to see the question.
Yeah.
I totally failed to be able to connect to Slack. So I'm in the loop of my password and account problem. So yeah. I can't get there.
So let's see. We have a question from Kennedy. Kennedy is into security chaos engineering.
Cool.
That's really cool. So, okay, my deployment stopped. That's strange.
So what's the question? Maybe I can address the question while you.
The question in the meantime. I've done experiments to verify the reaction of AWS security services with regards to detective following a malicious action. This would be very effective ways to conducting security chaos engineering on AWS, extending the test to confidentiality and integrity. Mm-hmm. Question is, do you have encounters with customers wanting such products?
100%. There's definitely a big demand. I think the only issue is people are not talking too much, or they don't necessarily talk in the sense of chaos engineering, but they definitely talk about it in the sense of security. I think it's just the term chaos engineering applied to security is fairly recent. It's just now starting to really reach mainstream in a way. Even chaos practitioner mainstream. So give it a couple of years, and it's going to be, I think, a very, very good way to learn about security and how to deal with security, and have more experiments around that. I know the folks at Chaos Toolkit, so Chaos IQ, and Verica are very keen on talking about that. So
Yep.
yeah.
And do you think the security perspective might be a even easier way of reaching C-level executives?
Yeah, I mean, yeah, it's actually a very good point. And definitely, at least it's a very good way to put it on the radar of, when I think when you include the word security in any communication, people open the eyes and ears a lot more versus if you talk about resiliency. So I mean, yeah, it's a good point. I think maybe it's a good way to start. Chaos engineering is via security. Maybe we've done it all wrong all these years, trying to do it through resiliency, and actually maybe security is the way to go, and start the work there. That's a good point. Yeah.
That's interesting. All right, so jumping back to my slow demo. So we're now in co-deploy, and it has started the deployment there, which then means that so it has started with the traffic shifting. So 10% of traffic has shifted to the new version, and 90% is still on the original. So let's see then. Yeah. So this is what the site looks like now, with an highlighted error code just for show. So as we can see, everyone gets a 200 response. One gets a 404. None gets a 404, and so on.
But on top of that, you have the rate here, right? It's not, so it's using the canary release plus the rate of.
No, the rate was at 1,
okay.
So it should be on all. But so I think it's fairly right that it's about 1 or 2 per reload. But this shows what you talked about, that this is per invocation. So 10%, about 10% of invocations get the new code.
Yeah.
And with the way we build serverless applications using functions, that means that we have the potential for injecting the failure to all users, since it depends exactly on when they're doing their invocation. So using the canary straight off using versions in Lambda will probably give you an end result that is not what you're looking for, because you can't really control which are those 10% of users. So
well, I guess you can still get a lot of information based on that, right? You can. It's just a matter, you won't be able to focus on particular user, right? So it will be on the bigger scale. And this is exactly why I said before that, like, maybe you want to be sure that to think about it, but some experiment definitely don't need necessarily user routing, right? You just need random experiments. So.
Yeah, and as you said, talked about feature flags, for instance. So once again, perhaps involving the front end developers for using this in the correct fashion. So using the chaos experiment as a feature that is enabled for certain users. Different stages using API gateway, for instance, might be an easier way of getting that exact
this is very good point.
Behavior.
It's great.
Yeah. So, but as we can see, based on the experiment, it works. We're able to do it this way. So we still have the rate of 1, so we're injecting on every invocation, but only 10% of the invocations has the new code where the experiment is enabled.
Awesome. Well done for the. I know it was short notice because let's tell to the audience, we talked about that a few days ago, right? So
Yep.
Gunnar was like, "Oh, I need to build this," and that was it. That's awesome.
Well, I like to visualize things. That's I like that way of doing it. So this is something to expand on, definitely, and do more, because I think this might be something that helps others to get started using it as well.
Yeah, and it's even if you don't do chaos engineering experiment, it's a right way to deploy your Lambda function, right?
Yes.
It's crazy to just deploy on top of another 100% to everyone. It's automation by canaries is definitely the way to go for deploying.
Now the rest of the 90% are in error state. So that's a successful experiment.
That's awesome. It's like 5 minutes, right? It's like boom.
Yeah.
Exploded.
Yep. Well, it worked.
But
right.
The good thing, I mean, it's brilliant, because you see, like, if you would have been monitoring and you've seen some errors, you definitely would have rollbacked already. You wouldn't have and you can integrate your error detection within the canary deployment at code deploy to actually roll back if you have some errors. So this
and you can. I was using the serverless framework, so you can integrate it directly there. And if you're using SAM, for instance, instead, you can do the same thing.
Yeah.
Not even using plugins. So it's really easy to do it that way.
Yeah.
That's a good point.
So I think the next version of the demo is noticing that there are errors and rolling back, because basically your steady state is changed, right? Your UI is not behaving the way it should.
Exactly.
It's cool.
We have another question from James. If you would like to experiment with chaos locally, do you normally use Docker to restrict resources?
I use Docker in my my answer is yes. I use Docker a lot. I do Docker stops, random things, but that's just one part of the experiment. Locally, you can still use, for example, stressng. You can still use IP tables, TC. You can still do a lot of application level failure, kill processes. To see, for example, because you have a Docker container, right, and you still have an application running there. You can kill the process in the container and see, do you have a manager like systemd or something, or supervisor for Python that actually detects that your application has been killed? Does it restart it automatically? All this kind of stuff. And when you kill a Docker container, do you have again the orchestration that detects there's something going on? Is your health check being triggered? There's tons of stuff. I've put some demos on my YouTube my YouTube channel of 3 videos where I use Docker, and I talk about how I started with chaos engineering locally, and kind of how to the mindset behind this. And there's another tool, WRK, which is kind of load testing locally, then add latency, and you'll figure out tons of stuff in your application.
Yeah, that's great. So, are there any other questions in Slack? Nothing right now. So, if there aren't any other questions right now, I think it's time to wrap it up, Adrian.
Already? It's been, oh wow, oh yeah, it's 10 to 9. Oh my god, the time flies. Dude.
Yeah, it does. Well, it's been great having you. It's been awesome to talk. We've worked with this side by side for a few years now, but this is the first time we're actually doing something together.
Yeah, it's dude, it's been like years we know each other. So for me, it's always such a pleasure to talk with you and being on the same stream and stuff, and talk chaos with you. It's yeah, it's like being home for me. So
Yeah, the same.
thanks,
Right back at you.
thanks a lot for having me there and organizing all that. And actually, the demos, I just love that stuff. What you do, mate. Yeah, so it's great.
That's great. All right. So thanks to everyone watching, home or at the office or wherever you are. Thanks once again to Adrian. And if you like this, well, then we might have a version 2.0 sometime in the future, right?
Always on. There's the canary release.
Yeah, with the canary release. That's great. All right. Thank you, everyone, and have a safe evening.
Bye bye.
Bye-bye.